Okay, for number 10, we're given a polar curve. R is a function of theta, parametric equation. I want to just point out there's footnotes over here. You can read through those footnotes if you want. We'll certainly go through it at the whiteboard. They tell you x equals, it's r cosine theta, but we're saying r is a function of theta, right? And y equals, r times sine theta, where r is a function of theta. Then they go on to say the derivative dy dx is this complicated expression over here. I surely want to go to the whiteboard and talk through this over here. After I talk through this over here, what we're going to do is answer the question, all right? In addition to that, I want to point out we do provide a graph. Although not asked, we do provide what the tangent line looks like, and certainly provide a graph for it. We do recommend you look at that, all right? So I want to go to the whiteboard, and as I go to the whiteboard, one step at a time. And again, if you understand this stuff, there's no real reason to watch this stuff. I'm going to do the whiteboard now. And again, what I'm going to write down is some things that we do know, all right? So we know that x equals r times the cosine of theta. Now, I'm going to say r is some function of theta. I don't know what it is, but certainly when we write a problem down, we'll know what that r is. What I'm going to do now is just write down, x equals not r, but f of theta times the cosine of theta. And I know y is equal to r times the sine of theta, right? So what am I going to do now? Write down y, and r is a function of theta. Okay, what I want to do is write down dx d theta. I'm looking at this to do that. That's going to be a product rule. So I'm going to say, f of theta, let's see, times the derivative of cosine is minus sine, plus f prime of theta times the cosine of theta. I'm going to write dy d theta now. And what do you get there? Again, we're looking at this. I'm going to say f of theta times cosine of theta. And then I'm going to write down plus f prime, using a product rule, times the sine of theta. What do I want to do? I want to find dy dx. It'll be the ratio of these two. I'm going to put that down, dy d theta. I'm looking at this now. I'll write that down. That's going to be, let's see, f of theta times cosine of theta plus f prime of theta times sine of theta. All right? What goes on bottom? It's dx d theta. I'm going to write in a different order, though. Looking at this, the reason I don't like that minus sign in front. And I'm going to write down is f prime of theta times cosine of theta minus f of theta times sine of theta. All right? So what I'd recommend you do now is just, look back over the notes now and verify this, that dy dx, this is written in your notes, by the way, is equal to f of theta cosine theta plus f prime of theta sine theta divided by f prime of theta times cosine of theta minus f of theta sine theta. It looks good, all right? Now, what I want to do is now talk about what the function is now. So it says, polar curve, blah, blah, blah. It says find the slope of the tangent line 2. Let me write this down now. They're saying r equals 2 theta. All right? And what we need to do is we need to find out the slope of the tangent line, dy dx, at the point where theta is equal to 3 pi over 2. All right? That's what they want me to write down. Now, looking at this thing, I do need dy dx, and I kind of have it. I know what r is. R is a function of theta. So let's write this down. Dy dx equals, well, I'm just looking at this over here and writing down exactly what I say. What's f of theta? 2 theta times cosine theta plus, what's f prime? let's see, it's going to be 2. Again, I'm looking at this now, times sine theta. Let's keep moving along. What's f prime of theta? I'm at the bottom now. That's 2 times cosine theta minus f of theta, which is 2 theta, times the sine of theta. What do I want to do? I want to do dy dx when theta is equal to 3 pi over 2. All right, let's write this down. 2 times 3 pi over 2 is 3 pi. The cosine of 3 pi over 2 is 0. Plus 2 times the sine of 3 pi over 2 is going to be minus 1. Let's keep doing it. 2 cosine of theta is 0 minus twice theta, which is 3 pi, times the sine of theta, and the sine of theta is going to be minus 1. I need to simplify that. And what do you get on top? We're looking at it relatively simple. It's just simply minus 2. On bottom, relatively simple. It's just 3 pi. So this is dy dx when theta is equal to 3 pi over 2. Right. Again, I want to emphasize that was the question they asked for. And, certainly I'd be looking at the answer key and making sure that that's what I got over here, that this is the answer that's listed in the key. All right, that is minus 2 over 3 pi. Now, I went a little bit further than that, and what I did was I graphed it, and I wrote down the equation of the tangent line. Let's do that. Let's write down the equation of the tangent line now. I need a point, and the point I need is where theta is 3 pi over 2. What's x equal to? Well, it's equal to r. What's r? It's 2 theta times the cosine of theta. What's y? 2 theta times the sine of theta. All right, let's go for it. It's going to be 2 times the point, which is 3 pi over 2. That's 3 pi. And again, the cosine of 3 pi over 2 is going to be 0. What's this going to be? 3 pi times minus 1. What do you get here? 0. What do you get over there? You can get minus 3 pi. All right, let's write the equation of the tangent line down. And that's going to be y minus y1, that's plus 3 pi, equals the slope. The slope we determine is minus 2 over 3 pi, and then x minus 0. Let's rewrite it as y equals minus 2 over 3 pi x minus 3 pi. This is certainly listed in your notes. Again, it wasn't asked, you weren't asked for that, but I'm going to say it's pretty easy to do that. All right, so I'm going to circle this over here, indicating it's probably something you should be practicing anyway. So minus 2 over 3 pi times x minus 3 pi. A graph is also provided for you, and certainly I'm going to say that it's not a difficult graph to do, but the bottom line is, I could never do a graph as well as a machine does. So it means something like this over here, and this thing kind of spins around, and you get a tangent line over here. And that was what the tangent line would look like. We're done. Thank you.